Hello Internet! Today we're going back to our graph component, and we're going to be adding a little bit of a nicer editor experience to how this whole thing works. So right now we've been using gizmos to kind of draw a graph. And that's fine, we get this, but it could be better. And so that's sort of what I'm hoping to do in this video. I want to transfer from using gizmos like we're using here to using handles in a custom editor, and also adding some extra editor components so we can create something that's a bit more complex than this 3-node, 1-edge graph we have. I've kind of got like a really basic framework going. We have a custom editor that displays the number of nodes and edges in our graph. And so I've made a few modifications to get that working. The first one, this is not what I want. The first one is I made this. So there's now a public property called uppercase graph that just returns the graph. This gives us a way to access this reference. We can't erase it because it's just a getter, but we can access it and use that to actually pull out like the nodes and the edges. And then in the graph editor, there's two components here. It's going to be a custom editor, so it's extending the editor class, and it's inside of an editor folder in Unity. And this has an OnInspector GUI, which is what we're using right now. And that draws the number of nodes and the number of edges. And then OnSceneGUI, which we're going to use to draw our handles. Handles are pretty much everything you interact with in Unity. So this classic like 3-arrow symbol, this is a handle in Unity. And so you can use them to create much more interactable things. You can actually create this exact component and inject it into your scenes. And that makes it sort of useful for actually editing these kinds of things. And so hopefully we can combine both of those and get an actually really nice experience that works quite well. At least that's the idea. So let's see what we come up with. I don't entirely know what this is going to look like or how this is going to go or what's going to happen. It just seemed like something that would be fun to add, and I've never really had much success with handles before. So that might totally explode, but hopefully we can actually learn something from it, and I'm hoping that I'll be able to actually know how to use them at the end of this. So the first thing I want to do, I think, is to draw a transform for each node so that we can modify the position of the nodes. And I don't need to remove the gizmos component for this. All I need to do is add handles for it. And so what we're going to do is, I should talk about this first part first. When you use a custom editor, there's a target component. That target component is going to be the game or the mono behavior that's attached to it. What I'm doing is casting it over to a graph component using as. The way as works is it attempts to cast it to the type you give it. If that doesn't work, it returns null. So if you typically cast it like this, for example, so if you were to write this would throw an exception if this couldn't happen. That isn't always a good behavior. At least in this case, we would just want it to return null, so we can say exit out, we don't want to show this editor. And so that's all that's happening. And then after this point, graph should have a component that is a graph that we can use. And so hopefully this just works. So what I want to do is for each node, let's just do a for each. For each node in our graph nodes, graph.graph.nodes, of course. That might get a bit confusing. So graph is the name of our reference to the graph component, and then graph, capital G, is the property here. Not the best naming. We might want to pull that out. But what we can do with this is then do a handles. And so this is a custom Unity editor script, and there's a whole bunch of functions in here designed for drawing things in the editor. And what I want is a position handle. And so this takes a position and a quaternion and returns the new position. So you could effectively modify the position. And so what we're going to do is just give the nodes the value, which should be its position. And we'll just use the identity quaternion, so that will move it along the standard XYZ axis. If we gave it something else, it would actually rotate that gizmo, and so we could move it in a different space. I don't want that, so we're just going to use the identity matrix, or identity quaternion. And then all we need to do at the other end is just assign the value there. And so this is just going to be constantly repeating every frame and replacing the position, the value of our node, with a new position. The downside of this is it means that it only works for graphs that are vector 3 and eventually float. But that's fine, because that's sort of what we're going to be using this for. You need a different editor if you wanted to use a different type of generic implementation of our original graph. But we're not going to do that. So, and so what we should see here is we should see these new transformation things. And so these spheres that are being drawn and this yellow line is our nodes and edges being drawn as gizmos. And so as I move this using these handles, we're actually changing where those nodes are. And so this is sort of like the easiest way I know of to modify things like this, because we don't have any extra game objects, we don't have anything else. We just created this editor UI that allows us to do things like this. And that's pretty cool. So that's sort of what we're going to be working with. This gives us a way to modify our components, but we can do a little bit more with this. That was really like the big thing I wanted to get done. But we can actually start replacing this other gizmo stuff so that our graph component becomes a little bit easier to use. I don't need the Bezier curve one. That was a different experiment. Let's see here. Handles, position handle. Cool. For these nodes, we also need to draw some sort of color. So I believe it works similar to gizmos. Like I said, not super familiar. Let's just do a color and say it should be equal to the node color. And so that should assign our color to the handle color. So that should actually change the color of our handle. So if we do handles dot sphere, draw a sphere. Control IDs, I believe you need to actually create a control for this to work. And I haven't done that. So I'm going to give it 0. I'm pretty sure that's going to break. I may need to actually go and look up documentation for that. So if we don't see this, that's what's happening. But we're going to try it anyway. And then we'll do the node value for the position, the quaternion identity. I don't know why we need a quaternion for a sphere, but okay. And then we'll give it the size of 1. It doesn't like this. Sphere cap. So I might be screwing this up. There is a way where you design custom handles, and this might be part of that. We're going to find out. Again, figuring this out at the same time you are, so or you probably actually know more than I do, to be completely honest. But we're gonna see what happens. And so our node should have a size of this. So let's plug that in. Sphere handle cap. Replacing a deprecated function with a deprecated function that's replaced with a deprecated. Okay. Anyway, there is no argument given that corresponds to the required formula. We need an event type. Event type dot something. That should be a capital E. Event type. There's a whole bunch of events that you can make your handles react to. Let's do none. So we're just going to ignore that for now, because that just makes way more sense. I think we can make it actually react to that. Ideally, I'd like to be able to like select a bunch of different nodes in this, but I don't know how to do that, so we're not going to. So theoretically, we have a sphere handle cap, which means I should, emphasis on the should, be able to remove that. And we should still see the nodes get drawn, if this works. If this doesn't work, we'll just see a single line, and then those position handles. And if we do, then I've screwed something up. But hopefully those 3 points stay there after this compiles. And they didn't, so we've messed this up. GUI error. Object reference not set to an instance of an object. Make sure they are balanced. Okay. We need to do something with these control IDs, I think. So handles dot create handles utility. That's a thing, right? Yeah. Handle utility dot add control. And we'll add control I with a distance of 1. I don't know what the distance is, but we're gonna guess. I've seen this used before. I don't know what it's for. So we're gonna find out. We'll do I++. So that should increment our I component, and then we can do some sort of var I equals 0. And so my assumption here is that we need to initialize this somehow. So let's do I++. Let's just do I, and I. My assumption is that you need some sort of control created for each of these components. And so that's what we're going to do here. And then we're going to reference it right there. And then, yeah, I think that's it, honestly. And then the only other thing we need to do is increment this I, so I++. It's a weird one-line thing, but that's fine. So create component, reference component, and then move to the next component is what happens on those 3 lines. Maybe that'll help. It might help fix our GUI errors. It doesn't look like it has, though. All right, I'm gonna go actually figure out how to use this, because I should probably do that. So I'll be right back, and we'll actually know what to do to get this sphere handle cap to draw. Okay, I think I figured this out. There's a repaint event. You can detect the number of the event that's happening. Unity's documentation actually is pretty all right for this function. And the way they do it is they don't do that incrementing index. That actually is something entirely different from what I was thinking. Instead, they detect when there's a repaint event, which would be when the screen is being redrawn. And they just have their handles react to that repaint event. And so that causes them to just be redrawn. And we have this if here that just actually detects that. And then the other thing I've done, we were getting a null pointer of object reference not found here on line 31. I'm pretty sure what's happening is our graph was undefined on like the first frame. We hadn't called start yet. And so because of that, we didn't actually have a graph. And so I'm adding this here. So this is an extra or graph.graph equal to null. And so when that will get called whenever our graph hasn't been initialized yet, and will cause it to just exit out. So hopefully that gets rid of our null exception and causes them to draw. I've already tested the spheres drawing. That works. So we actually have spheres now. And it doesn't look like it got rid of those errors. But that should be fine. Let's do the next bit, which is the edges. So we should just be able to copy this and move it over. I should save. There we go. Move it over here and do for each graph.edges. And they're doing gizmo stuff. We don't want that. Instead, we want our handle color equal to the edge.edge color, like so. And then we want to draw a line. We can actually do this already. That most of the same gizmo things that you were doing previously are in the handles as well. They just have a little bit more functionality because they're actually designed to be interactable, whereas gizmos are typically not. They're just displaying information. So, oops, that's not right. Handles dot draw line, like so. I actually wanted to keep the gizmo thing, because I should just be able to do handles dot draw line and replace everything, and that should solve it. And that's it. Is there anything else we need? Nope. I guess that's it. So that yellow line shouldn't change. Yeah. The only thing that's slightly changed is I think it moved in front of this one, but that's fine. So now what we can do is we can actually move our graph components around. So I can manipulate the nodes and things like that. It's not being serialized, and because it's not a gizmo, it goes away when it's not selected. I think, though, it doesn't display in game mode either. So yeah, I guess it's sort of a trade-off there. You do lose it in game mode, but you get it a more interactive version. Like if you want an editor experience, I think this is better. If you want a debugging experience, I think Gizmos works better. Just from like however long this has been, 10, 15 minutes of playing with it. So yeah, the next thing I want to do is actually make it so we can add this, and then I want to be able to add new nodes and add edges between nodes, which I should probably do in a separate video, but we're going to do it in this video because and so what I'm thinking the idea is I'm going to list all the nodes, and that will be the first thing we do. And so for each node, like this, I need to copy this logic up here. I could probably pull that out into a function, but we're not going to do that. Instead, we're just going to copy this and do that for each node. Cool. And then we can just do editor.GUI layout. Not like that. What am I doing? And we will do a vector3 field. And so we should be able to give this the node.value. And that should draw every node with a actual vector3 field. Oh, hold on. Ooh, we need to actually give it a thing. So let's just do node. So it needs a label. I suppose I could just leave it empty. Yeah, let's leave it empty. That should be fine. And so we should just get a whole list of vector3 fields. Well, we'll get 3. We'll also want to figure out how to serialize this, but I'm not going to solve that in this video. Like, hard no on that. We do get 3 things, and so I should be able to modify. Oh. Huh. We don't invalidate our inspector input when we modify these. And so it's not even causing it to trigger an update. Well, that's fun. We should probably do that. Oh, because we're not node.value equals that. Am I doing that here too? Yeah, I have to be. Okay, well that's odd. But there we go. And when you reload, it does work. So it doesn't get detected when I slide these. There's a function that we'll need to call to actually force a refresh. The dirty bit. How do we do that? Editor GUI layout dot dirty. Dirty. What was it called? So there's something that tells the editor that it is not, or something has changed. Action key, indent level, show mixed value. None of those look correct. Can cache inspector GUI. This dot set dirty. There we go. True. Oh, it doesn't actually take anything. Editor utility. Okay, so the function is editor utility dot utility. There we go. Set dirty. The corresponds to the required formal parameter target of that. Let's just set the graph to be dirty. I don't know if I'm doing this right either. But the general idea here is Unity's editor is smart, which means it's going to attempt to not redraw everything every frame. It's only going to redraw the things that have changed. In our case, because we have a custom editor, it's not detecting that things are changing. And so we have to tell it things are changing. And now that I do that, you can see that it does update in our graph component thing. The way I'm doing this is not correct. What I should be doing is figuring out if something changed and then saying it's dirty. I'm not doing that. And so this is going to be pretty poor performance. And that's not great. It also takes a little bit longer to set that all up. So I will, in the code that I upload for this, I will have fixed that, but not in this video, if that makes any sense. Hopefully that's all right, because we have to actually figure out how to detect these changes. And it's not too difficult, but I don't want to get into a whole bunch of different things because we're already doing a lot. So that's that. So what we're doing here is we have a series of nodes, and those are the nodes. What I want to be able to do is add a new node. So let's set that up. The way that works is it's going to be an editor GUI layout dot button. Is there no button? Or I need to go into some other thing, right? Seems like it. Okay, well that's fun. Editor GUI utility dot button. Drop down button. Hold on. There was 100% something you could click and it would do a thing. Why am I totally forgetting where it is? I'm gonna go figure out where the buttons are. That's a weird thing to say. I could have sworn. Oh wait, I remember. They're in here. Dot button? Or were they removed? Maybe they were just taken out. GUI layout. Oh, there they are. Okay. Fun. I had totally forgotten about that. But we will do add node. And we want this to be a if statement. For whatever reason, the editor GUI layout doesn't have a button. Most of the other things between the editor GUI layout and the GUI layout are the same, but the button isn't. It's been like that for a while, and I'm not entirely sure why. But this seems to work because I think they both do the same things. So, But anyway, getting distracted again. When this happens, we want to go to our graph.nodes.add, and we want to do a new That's not right. New node with a position, with a value, sorry, equal, what? Oh, vector 3. With a value equal to vector3.0. And we can set the color, let's not even set the color, let's just leave it like that. And so that creates a new node, great. And it should just get added to our scene. We may or may not see it. It might just get like an empty color, in which case it'd be hard to see, but we should definitely see it in the inspector. And I can raise it, and the orb is transparent, but the handle is not. So we can also change it like this just by moving it, and it functions like any other node would. We're just adding additional ones, and we can just keep going. Cool. So that works. Next thing, I want to display outgoing nodes or outgoing edges from the nodes. So for every node, it has a certain number of outgoing edges. So if the from part of our edge, our edges have from and to, if the from is equal to the node that it's a child of, then I want to display it. And if not, then we just won't. It's not a child of that. That might be a weird UI experience, but that to me makes the most sense. So that's what we're going to do. The easiest way to do that, to my knowledge, is just to do a loop inside of a loop, like this, which is not great, but it works. We can improve this, I guess, a little bit if we need to, but we probably don't need to. And so this is just going to display editor GUI layout dot. What do we want to display here? We could display the begin horizontal group. Let's do that. And end horizontal. And so the idea here is this will allow us to start tiling things horizontally in our layout instead of vertically like it was doing. And so we can put things beside one another. So if we do an editor GUI layout dot float field, we can use this to store our value. We want to store the edge dot value, and so that's going to actually display the weight of our edges. And then the next thing we want to display is going to be our we want to save this, so edge dot value equals that. That way it will actually persist, otherwise it would just go off into the void every time we entered something, and we don't want that. The next thing is going to be a from, so edge actually, and then we want it to be a to. And I'm going to add one other thing. We will do a field or a label field. And we're just going to do like a really basic arrow here that just kind of points and says this is going to this node dot to the value or to the color. That's kind of hard. Let's do to the color, because that could be kind of fun. I want this to be read only though. So GUI layout option GUI layout dot. I don't know the thing for that, so we're just gonna ignore that. But this shouldn't be editable. The color field should just be a information field. It should just display the color so you know where it's going to. That's only really helpful if the node is not is not duplicating colors. We have 2 with blue, So that's less useful. But you kind of get the idea, like you can kind of see that they're going to, why do they all, oh, because it's all displaying the same edge. Duh. We don't have any filters yet, so it's all the same. But that's the general idea. So I think that sort of gets the general idea. It doesn't look pretty. Like it's not great, but that making it look pretty is more of a time investment than a can it be done investment. And so if you want to make it look good, you can do that. I'm just not going to invest that kind of time. Why did that happen? That was weird. I added 3 extra spaces, and for some reason we lost our color. Like the entire thing moved over like a full... That's interesting. I think those label fields are much bigger than I thought. So let's do a prefix field, or a prefix label, and do 3 spaces. It seems like those are like a full half a thing, and that I wasn't expecting that. Yeah, that makes way more sense. Still very big, but not as big, so I think that's fine. So anyway, we have the weights, we have the color. It means it's going from this red one to this blue one up there. That's sort of what we're getting out of this information. We just don't have a filter. And so what we actually want is a where clause here from link. And what we can do is plug in our edge, where the edge.from is equal to the node. And so if the from value of the edge that we're iterating over is equal to the node that we're currently looking at, then we know that it's a child and we should draw it. Otherwise we won't, because it will get skipped over because of the where. And so hopefully this should drop down to just one instance of a edge like that. Cool. So that's actually working. Great. Now the next final thing, hopefully. It's getting longer, I know, but there's so much stuff that I kind of wanted to do with this that we're just going to keep going. For the nodes, I want to be able to do something a little bit extra, I guess. I want to be able to add a new edge as well. Does it make sense to use the color? I'm feeling like the color makes less and less sense. Well, it will be fine. Let's add the color here as well. So we'll do node color equals the node color. Cool. So that's like a color editor, so you can actually change the color of nodes and see what color they are. So we can change the position and the color of them in the inspector. We're also going to add a button there. And this button, ooh, that's not right. If the button add edge, this is going to be a bit more fun. We're going to call an add edge function. And we're going to pass in the node, I guess. That should be everything that we actually need, hopefully. So we pass in the node. I should also probably pass in the graph. Well, I'll need to pass in the graph. So the node we're working with and the graph that we're a part of. Probably in the wrong order, but that's fine. And so I just want to see what this looks like. The function should function. It will throw an error when I click that button, but we're never going to click the button. So we should see this top, those numbers kind of change. Gets a little bit more dense, but that's fine. Now we have red, and I should be able to actually edit the colors now. So if I want this one to be like gold, you can see down here it turned into a gold node. And I should be able to add a new node and change it to, say, pink, we'll need an opacity. There we go. And now we have that fuchsia colored one up top. So we can actually create new nodes and do all that fun stuff. And it actually gets displayed. Cool. So I think we're making decent progress. Let's add an edge now. And so what I wanted to do is do a var menu equals new generic menu. Now I've never used these before either. I kind of stumbled upon these by accident, but this is a way to do a drop-down menu in Unity. And so the way this works is you would add an item, like your GUI content, the Boolean, and then the function. I don't know how any of this works. Maybe not the best idea, but the idea here is we could do like GUI content. Okay, I think that can just be a text. Pretty sure that should work. Bool on true. Member function. Does that work? Okay, it doesn't like that much. Add text string to Unity GUI content. It doesn't like that. So GUI layout dot button or dot text. No, that's going to return a string, and that makes sense. Okay, I'll need to figure out what that GUI content is. I had kind of assumed that I could just plug a string in, but I can't. So I'll be right back, figure that out, get this whole thing sorted, and then we can get it adding edges, and hopefully the whole thing will just come together and be nice. At least that's the idea. And before I go, this can just go away. We don't need gizmos as part of our component anymore because we have a custom editor for that. So it looks a little bit gross, but it works-ish. So I will be back once I know how to actually use this generic menu that I decided to use on a whim. So I think the way this works is we need a GUI content, right? I think we just do it this way and do like text. I think that works. And just for fun, let's do a new GameObject created via menu. So this, we don't need those brackets. There we go. So this should create a new GameObject every time we click this menu item in our generic menu. So we do menu.show, show as context, cool. And I think that's it. A bunch of hand waving there because this is hand waving, but it seemed to like that. It also didn't seem to like that. Where did our gizmos go? Did it just decide to... Ooh. Oh, because we don't call start. Oh. That makes total sense. We're never initializing this because I decided to put this in the start thing instead of right there. Right? I can just do that, and then we need this less. There's some slight caveats to this, but I can delete that as well, I think. And I said I wasn't going to do anything, but let's try serializing this field. Maybe it will save. Maybe. I don't know. Kind of a guess there, but I should be able to add a node. Let's do blue. Blue sounds fun. So we'll do blue and set that to like 2 over there. And then we can add an edge. We'll do text, and we get a created via menu GameObject. So that means that menu is working. So we can delete that and actually do what we wanted in here. And then when we come back to that graph, if that node still exists, then we know it was serialized because, or at least we know it isn't getting wiped out every time anymore, which would be great. So here we go. Inside of this menu, what we want is to make it possible to link to any edge that is not already linked or coming out. No, that's not what we want. We want to be able to link to any node that is not the node that we are already. So we're not going to have circular loops inside of our graph. So you can't have a node that links to itself, but you can link to anything else. And the only thing we're not going to display is things that already have a link to them. I don't know if we want that filter. Let's not actually do that logic at all. Let's just pretend like we're going to, and we'll do that later. Maybe. I don't actually know if we'll ever actually implement that, but we don't need to filter it just for like an example. We can just do it. So for each graph, oh, what am I doing? For each node in our graph.nodes, graph.graph.nodes. That's a weird relationship. Anyway, do this. Now we'll have a whole bunch of options, hopefully. Node cannot be declared in scope because there's already a node. Local node. Not a great name, but sure. Where n dot n is not node. So this is just going to filter out our current node. So that's not displayed as a potential candidate to link to, so you can't create a connection back to yourself. Everything else is valid. And then what we're doing here, we are going to add a new menu item to each of those positions. So to the local node, let's actually do this right. Local node dot value. It doesn't like this, so let's interpolate the string. There we go. This is I've used this a few times already in this project, but this is C#7's string interpolation syntax. So if there's a $sign in front, you can put the curly brackets inside of it and then do scoped variables, and it will interpolate them for you as if you're like plussing them into a string. It's sort of like a fun little way to do that. I have a video on that if you're interested. That goes a little bit more into it, but that's that. This. Oh, that's just to see if it's checked or not. Oh, we could do this to like enable or disable them. Anyway, that doesn't need to be anything. Add item. Add separator disabled item. Okay, so it's just like a toggle list. Fine. Add item. False. And if this is true, what we want to do is do this to that. Great commentary. We want to create a Lambda function that is going to actually create the edge. So we have the node that we're going to. That's going to be the local node. And so what we want to do is create an edge between those two. So what that should look like is graph.edges.add a new edge of type float vector 3 with a value equal to 1. We don't have any dialog or anything for giving a value yet, so you can change it in later, so I guess we'll just set it to 1. That seems to be our default for now. Our edge color equals color.white. This also can't be changed with the current setup, but that's fine. And then from is going to be equal to our node. and then 2 is going to be equal to the local node that we targeted. So we could actually change that to R. Ooh, that's not right. I pressed the wrong set of buttons. Hold on. Local node F12. No. F2. Okay. Target node. So much trouble just trying to use the wrong hotkey. All right. So now target node is what we're calling this. So the target node is going to be displayed as the value. So you'll see the position of the target node and select where you want it to go. And then it will create a link from the current node to the target node. And that link will be white with a weight of 1. I think that makes sense. Let's see if that actually made any amount of actual program sense. We lost all of our data. That's too bad. So let's add 2 nodes. And we'll just do x minus 1 and x plus 1. And then we'll add an edge from x to x minus 1. And this is a directed graph, actually. So now that I'm thinking about this, we could use even more of the fun things. You can create these arrows and things that are used here, and they don't need to be for transformation things. We could just have an arrow going from one node to the other as a way to represent the direction of the connection, because right now that doesn't exist. That might be a good thing to do, but we're not going to. So, ooh, that's black. There we go. So there are our 2 nodes, and we can add all the edges and do all those fun things. And it kind of displays this fun little menu to select them. And I think that's pretty much it. There's other things we could add functions or buttons to drop edges or drop nodes. But that's just extra stuff, I guess. There's not anything really unique happening there. We're just reusing a lot of the components we've already covered. These are not serializing. Serializable. Does this work? It's been a while since I've tried to do this. But it would be great to just get it to save without me having to go and manually or create another video to actually serialize these things. So we'll do that. I guess I can start this, reset it up, and then try to add the arrows for the directionality of these things. And then we can leave it there, I guess. Gold and blue. For some reason, I'm initializing these with an opacity of 0, which is the worst idea, but it seems to work. There's an edge done. And yeah, so it should go from gold to blue when we have this working. Let's save that scene and go back here, close that window, there we go. And so what we need to do is change this draw line to a handles.draw arrow. Is that all I need to do? 0. Oh. Draw a dotted line, draw a cap function, solid disk, polyline, convex polygon. There's a lot of options. Doesn't arrow handle cap? Well, that's going to be the one it's going to want us to use. Unfortunately, it doesn't seem like it has any actual thing to it. So I don't know if we can actually do anything fun with it. Like just do like a draw line, but just have from to to. Doesn't seem like that's an option, but we can just add the arrow function itself. And that'll be from edge.to.value. And just to test this out, we'll use the identity and just do like a 0.1 size with an event type of repaint. There we go. And just wrap this up in that test. There we go. There. All right. Rearranging things, but we have our arrow cap, which should be added at the end of the line. It will face the wrong way because that's just what's going to happen. It didn't serialize. Oh. All right, so there's that. We should get white lines, so I should just be able to move this. Oh. Oh. What? No. It draws a line with the arrow? Why does it do that? Oh, I don't know if I want it to do that. That may be less ideal. Though I suppose we can kind of use that to our advantage, because then we can do dot from and I think we can do a quaternion dot trs. Oh, that's not going to work. Dot look rotation. Forward is going to be edge dot to dot value minus edge dot from dot value with a size of the magnitude of that. So let's save this as some var diff equals that. Sorry, this is getting a little bit out of hand. But the idea here is to take a difference between the two vectors, the from and the to, get a direction towards it. So that will be our look direction. We can set that as the rotation, so we'll look in that direction and effectively point our arrow in that direction. And I think we need the size to be equal to how big this is, which means this needs to be equal to the magnitude. Diff.magnitude. This is all a guess. So we'll see what happens, but kind of want to see what happens. It might just all explode. But there's both that, do our arrow, and then move this. Ooh. So it does work. Just gets a bit big. maybe not what we wanted. Let's set the magnitude equal to a constant of like 1. And then this is going to be silly, but we can actually do edge.to.value minus the diff.normalized. So this will take this will subtract the normalized difference, effectively moving back 1 unit towards the from position. And then since this is a length of 1, theoretically this will just fill in the rest for our draw line. We can just have that draw all the way through anyway, because it should be fine. And if I am thinking about this right, this should mean that we actually have an arrow going into our point. Add 2 nodes, add an edge. This should go to our gold thing, like, or I guess our red thing, like so. Move it there. And we actually do get the arrow. We could modify this a little bit more to actually pull this point back a little bit so it doesn't go through the point. But that's just extra tweaking. So I think this is sort of where I wanted it to get. I'll probably post a slightly modified version of this with a little bit nicer layout and a few of these kind of things worked out. But hopefully this is at least an introduction to how handles work, how that generic menu works, and how you can kind of use all of that to build a really pretty editor script that actually is pretty useful. And we will pick this up to figure out how to actually serialize this thing, because we can't save it, and that makes it less useful. So ideally, we'll be able to serialize this, but we can add nodes or add edges back and forth, and everything just kind of works. So yeah, that's it for this video. So until next time, see you, internet.